Okay, here's your fourth attempt for problem number 1. First we need to label the congruent angles, sides, right angles, and parallel sides on the diagram over here. A square, you should know that all 4 sides are the same, so I mark those with tick marks. And you should know that all 4 corners are 90 degrees, right angles. Now this does get squishy. That was the bare minimum that I would require. We also have opposite sides are parallel, so I'll use the single marks there for parallel, and I'll use double for the top and bottom. So there's our markings for square. Scalene triangle, all 3 sides and all 3 angles are different, so if you left that blank, that would be acceptable since there's really nothing that is congruent to mark. If you wanted to mark it, you would need to identify that they're all different with 3 separate sets of tick marks. You could do the same thing for the angles, but I won't do that right now. Parallelogram, the opposite sides of the parallelogram are the same, so left and right, along with the top and bottom. And we have parallel sides opposite one another. That's the crucial one to know since it's a parallelogram. Hopefully that makes sense. And if you wanted to mark the opposite corners of that, you certainly could. I probably wouldn't check that, but the opposite corners are the same here and here. And now for regular meaning all sides are the same, we're going to mark all 5 sides are the same for this pentagon. And if they're all the same, then the angles are also all the same, so I could mark those too. So, which of these shapes has at least 2 sides congruent? Well, a square does, because all 4 sides are congruent. The parallelogram does, and the regular pentagon does. So technically A, B, and D could all fit this category. Has at least one angle less than 90 degrees. Well, for a square, they're all 90, so there's no square for this one, but there was a square here, so I'll stick A there. A scalene triangle has at least one angle that's less than 90. That's these 2 corners you see there. And it didn't have any congruent sides, so the scalene triangle will go here. Parallelogram has an angle that's less than 90 there, and it had 2 congruent sides, so it's both, so we stick that in this middle of our Venn diagram section, B. And for the regular pentagon, all 5 of the angles are larger than 90, called obtuse. So we don't fit that category for the regular pentagon, so just 2 congruent sides for the regular pentagon here, D. Okay, that was 1A. Let's slide it up. We'll try 1B. Right triangle means we got to insert our right angle box in that corner. Isosceles means we have 2 sides of the same, so these 2 sides here would be the same. And because they're the same, the angles opposite them would also be the same, so I'll mark those. Here's our parallelogram, same one we had up above, except it's turned a little bit. Those 2 sides are the same. The opposite 2 sides are the same. They are also parallel, left and right, and top and bottom. And you can mark opposite angles are the same. Isosceles trapezoid, 2 sides are the same. That's what isosceles means. So we got 2 sides are the same. That means the angles in those corners opposite them are also the same. And trapezoids have parallel bases, so the top with the bottom would be parallel. We can also mark that these angles here in the corner are the same, but I wouldn't require you to do that. It's a tough one to see. Again, we have scalene triangle where all 3 sides are different. If you left that one blank, that would be fine. Alright, let's head to our Venn diagram. We have a line of symmetry for a right isosceles triangle. That would be right about there. If you drew that line and folded it across that line, those shapes would overlap one another exactly. So our right isosceles triangle will fit this one. Let's go ahead and try it this way. Has at least 2 congruent sides. Yes, 2 congruent sides, so the right isosceles triangle fits both of these categories. We'll put that in the middle. Line of symmetry for a parallelogram, actually it doesn't. There's no way to draw a line and fold it across that line and have the shape overlap. So it does not have a line of symmetry, but it has two sides that are congruent. So we'll put the parallelogram over here. An isosceles trapezoid does not have a line of symmetry, but it does have two sides that are congruent, so we'll put that over here. And a scalene triangle is neither a line of symmetry or two sides congruent. So we have to stick that outside of our circles for the Venn diagram because it doesn't fit either one. So hopefully you got these two finished. Make sure you finish C down below after you printed it. Bring that and all of this completed in order to earn a 4th try on problem number 1.